Hey there, YouTube family. Welcome back to our channel. If you're interested in the fascinating world of machine learning and artificial intelligence, you've landed in the right place. Today, we're diving into the concepts of overfitting and underfitting, two critical phenomena in the machine learning landscape that can make or break your models. So, grab a snack, sit back, and let's get started. Now, before we jump into the nitty-gritty, let's ask ourselves a key question. What happens when our machine learning model doesn't perform as expected? Well, it usually boils down to two terms you need to know: overfitting and underfitting. But what do they really mean? Let's break them down. First up, let's talk about overfitting. Picture this: you're trying to teach a computer to recognize cats in photos. You feed it a dataset full of cat pictures, but you happen to include some images that are very unique, like a fluffy Persian cat wearing a bow tie. Now, if your model learns every minute detail of these unique pictures, it might become too specialized. It could perfectly identify that one bow-tied Persian cat but struggle with other, more typical cats. Overfitting occurs when a model learns not just the underlying patterns in the data but also the noise, those irrelevant details that don't generalize well to new data. In graphs, overfitting looks like this. Imagine a line that twists and turns dramatically to touch every single data point. This line fits the training data perfectly but fails miserably when faced with new, unseen data. The model has essentially memorized the training data rather than learned from it. A classic example of overfitting can be seen in polynomial regression. If we fit a high-degree polynomial to a small set of data points, we might get a beautiful, wavy curve that passes through every point. But this curve is unlikely to perform well on new data, signifying that it's overfitted. Now, how can we tell if our model is overfitting? One way is to look at the performance on both the training set and a validation set. If your training accuracy is high, but your validation accuracy is significantly lower, that's a red flag for overfitting. So, how can we combat overfitting? Here are some strategies: simplifying the model, regularization, cross-validation, early stopping. Now, let's shift gears and talk about underfitting. Consider this: you're back at it with a cat recognition task, but this time you decide to use a very simple model, let's say a basic linear classifier. This model may only consider one feature, like the number of legs, which doesn't help in distinguishing cats from dogs. Underfitting happens when your model is too simple to capture the underlying trend of the data. It fails to learn both the nuances and the basic patterns, leading to poor performance on both training and validation datasets. In graphical terms, underfitting looks like a straight line that barely touches the data points at all. The model is not flexible enough to capture the complexity of the dataset. An example of underfitting can be seen in linear regression applied to a non-linear dataset. The linear model will likely perform poorly because it can't capture the curvature of the data distribution. So, how can we identify underfitting? A straightforward way is to look at the training accuracy. If it's low, it indicates that the model isn't learning enough from the data. To address underfitting, you can increase model complexity, feature engineering, remove noise. Alright, folks. To sum it all up, overfitting and underfitting are two sides of the same coin in machine learning. Overfitting is when your model learns the training data too well, including its noise, while underfitting is when it fails to grasp the underlying patterns because it's too simplistic. Understanding these concepts is crucial for creating effective machine learning models that generalize well to new data. If you found this video helpful, don't forget to hit that like button, subscribe for more educational content, and share your thoughts in the comments below. What topics would you like us to cover next? Until next time, keep learning and stay curious. Bye for now.